Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 11.1 entitled Proportions. And today we're going to be using cross-multiplying, distributing, and factoring to solve proportions. And we're also going to write and solve proportions that are describing a word problem. And a proportion is really just an equation that sets two ratios equal to each other. Or it's a fraction set equal to another fraction. And the way that we solve a proportion is that we cross multiply. So here, even though we have all variables, when we cross multiply, we will take the a times the d, and then we'll set it equal to b times c. So sometimes students like to draw in that little crisscross. Sometimes a common mistake is that students will write a times d over b times c. They keep it as a big fraction, and that is what you do not want to do. That's a common mistake. It needs to be an equation. It has an equal sign in it. So after we do our cross multiplication, it takes fractions that are in an equation and just makes it a linear equation where we don't have any fractions at all. And that's easy to simplify then, because then we can combine like terms or undo addition and subtraction, undo multiplication and division. So once it's out of the proportion form, then it's much easier to solve. So let's take a look at a couple straightforward proportion type problems. This first one here, we have 72 over 96 equals x over 4. And it says to solve it, we have one variable here, x, so that's what we're going to be solving for. I have one fraction set equal to another fraction, so I'm going to cross multiply. So I'll have 72 times 4 equals, remember it has to be an equation, it's not a fraction, and then the 96 times x. Now we can actually simplify the 72 times 4, that's 288, and that's 96x. And then to solve for the x, we have to divide both sides by 96. And when we divide here, we get 3. So x is equal to 3. Now this is the algebraic way to solve this. Some students are very observant and they recognize that 72 over 96 is just a fraction, and you could put that into your calculator as a fraction using your fraction button and hit enter, and it would simplify and reduce it for you, and it would give you 3 over 4 as your answer. So then you would know that 3 is the value that we're looking there for x. So some students do make that observation for these very easy, straightforward proportions. And that's fine. That's a good way to double check your algebraic work. But when you see a problem like part B, it has a little bit more complicated term here. It has an x plus 1. So we have 4 over x plus 1 equals 7 over 2. And even though it looks a little more complicated, we're still going to start by cross multiplying. So we'll have 4 times 2 equals, and then here I'm going to write it as the 7 first, and then I'm going to put the x plus 1 in parentheses. Now we can multiply in any order. So if you think of this as x plus 1 times 7 or 7 times x plus 1, either way is correct because we can multiply in any order. But what you need to remember is that this x plus 1 is one whole term. So you can't just write 7x plus 1. You need those parentheses around the x plus 1, because now that tells us that I have to distribute the 7 to both of those terms. So I will get a 7x plus 7. And that's a common mistake that students make. They multiply the 7 by just the x or just the 1, but you have to multiply it to both of the terms. And then 4 times 2 is 8. So now I have more of a linear equation that I have to solve. Over here, I just had to divide by 96. This time, though, I have to subtract the 7. And I'll have 1 equals 7x, because the 7 and the minus 7 will cancel. And now I'll have to divide by the 7. Whoops. And I will get 1/7. for my answer. And sometimes students see a fraction for an answer and they think, oh no, I did it wrong. No, you didn't. It's okay to get fractions. Just make sure that you reduce them all the way. Okay, and part C is just one more step up. It looks a little bit more complicated. The only thing that's different is that we have a 2 in front of our x. Over here we didn't have anything in front of the x. It was just a 1x. Now we have 2 x's. So that means when I distribute, I'm just going to have to multiply this 1 by the 2x and by the 1. So again, even though it looks more complicated, it's still just cross multiplying. And it's a good habit to write out what you're actually multiplying first before you just do the multiplication. Some students like to do the multiplication in their head and then they miss parts that they're supposed to multiply. So 2 times 5 is 10. And then here I have to distribute the 1 to the 2x and to the 1. So I really just get the 2x plus 1. But if this was a different number, if this was a 10, then I would have 10 times 2, which would be 20, and then 10 times 1, which would be 10. So here it's a nice multiplication just because we have a 1 that we're multiplying by the 2x and the 1. But now I have to get all my like terms together, so I have to subtract the 1. So I get 9. That equals 2x. And then when I divide by the 2, so I can solve for x, I do get another fraction. I get 9 halves. Or you could write 4.5. Either way is okay. But those would be your values for x. So you can leave your answer as a mixed, or I'm sorry, an improper fraction, as long as it's reduced all the way. 9 over 2, we can't reduce that anymore. But I could actually divide it out and get the decimal for it, and that's fine too. Whichever answer you prefer is totally fine. Okay, now our next example has 4 parts to it, and this is going to be a little more complicated in our solving methods. Because now I don't have just one variable, I have 2 variables. Whoops. So when I have 2 variables, I have an m and an m, that could mean a couple different things. It means that I might have to get all my variables on one side of the equation, so that way I can solve. It might mean that I'll have a variable times a variable, so I will have something squared. So I might have to take the square root, or I might have to factor. So those are going to be the more complicated solving strategies that we're going to take a look at here in these examples. But again, I have a fraction set equal to another fraction, so I'm just going to cross multiply. And we should be getting good at recognizing that distribution now. So I'm going to have 5 times m minus 3. So here I'm going to distribute the 2 to the m and the 1. So 2m plus 2. I'm going to distribute the 5 to the m and the minus 3. So 5m minus 15. So now I have a variable on both sides of the equal sign. So I'm going to remember my problem solving strategies from back in chapter 3. And I'm going to pick on the little guy is just the phrase that we like to use. And that just means to move the smaller number to the side that has the larger number. So I'm going to subtract the 2m over to the side with the 5m because 5 has more. The only reason I do that is so that way when I subtract, my variable stays positive. 5 minus 2 is 3. You could just as easily subtract the 5m over to the left side. But then when you take 2 minus 5, you'd get a negative 3m. So just be aware that if you do that, you would have a negative number that you'd have to divide by. Not a big deal. But now that I have the 3m on the left side, I'm sorry, the right side, I'm going to have to add the 15 over to the left side. So here I'll get 17 equals 3m. Let me scooch down just a little here. And then I'll have to divide by the 3. And again, I'm going to get another fraction. That's okay. So I'm going to end up with 17 over 3. Okay, in the next problem, I am going to have to cross multiply again. And this time, you can see that when I cross multiply, my variables are actually going to get multiplied together. Here, when I cross multiplied, I ended up having a variable on the left side and a variable on the right side of the equation. But over here, when I cross multiply, I'm going to have a negative 3 times 3, so that'll be negative 9 in a moment. And then I'm going to have x times x plus 6. So I'm going to end up with an x squared. So negative 9 equals x squared now, because I'm distributing the x, plus 6x. So now I have an x squared and an x, and then a number. So this you need to think back to the previous chapter when we were talking about quadratics, and you have to remember that in order to solve this, you have to try to factor. So in order to do that, you have to have all your terms on the same side of the equal sign. And we want to move them all to the side where the x squared is going to be positive. So I'm going to move everything over to the right side. So I'll have 0 equals x squared plus 6x plus 9. Now you could solve this with the quadratic equation if you wanted to, but that's a little more time consuming. A faster way is to try and factor this with guess and check. So we want to set up our two parentheses. I'll need an x and an x. And then I need to think of the factors of 9 that will add up to 6. And the factors of 9 that add up to 6, if you need to write them down, you could think the factors of 9 are 1 and 9, or 3 and 3. And the factors that will add up to 6 are going to be 3 and 3. So I need a 3 here and a 3 here. And I'll need them both to be positive, so that way they add to 6 and multiply to a positive 9. So now that I have it factored, I can set each of these little parentheses equal to 0. This is using the product property, the 0 product property. And since they're exactly the same, I'm going to get the same answer here. When I subtract the 3 over, 0 minus 3 will be negative 3. And since they're the same answer, I really just need to write it down one time. X will equal negative 3. So remember, we want to keep the x squared positive. That saves us a step of having to factor out a negative 1 later. If I moved the x squared over to the left side here, it would be negative x squared. And I can't factor when that x term, that x squared term is negative. So I would have to take out a negative 1. I'd have to factor out a negative 1 or divide everything by negative 1. So by keeping that x squared positive, I'm just saving myself a step later on. Okay, so let's try 2 more where we have to do some more factoring, because this is really the most challenging type of problem. So again, I've got a fraction set equal to a fraction, so I'm going to cross multiply. So I'll have an x times an x. And again, it's good to write down what you're actually multiplying together before you try to do the multiplication. Usually students just kind of jump into multiplying in their head, and then they write down the wrong products. So x times x, I know is x squared. Now here, since I wrote this down nicely, I can see that I have to distribute. I have a number outside the parentheses, so that's a clue that I have to distribute the 4 to the x and the 1. Now again, I've got an x squared and an x term, just like we had in the previous example. So that means I have a quadratic that I'm going to have to try to factor, or I can use the quadratic formula. But in either case, I have to get it all set equal to 0, and I want to keep this x squared positive, so I'm going to subtract the 4x and add the 4 over to the left side of the equation. So then I'll have x squared minus 4x plus 4 equals 0. So now once it's all set equal to 0, if you wanted to do the quadratic formula, you could. You would have your a value is 1, b is negative 4, c is 4, And then you'd have to substitute it into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's a big substitution problem, but I think it's faster to do guess and check. And since this is 1x squared, I just need the factors of x and x, because x times x is x squared. And then the factors of 4 that are going to add up to a negative 4. Let's see, factors of 4 would be 1 and 4, or 2 and 2. And the only way I can get these to add or subtract up to a negative 4 is if I use the 2 and the 2 and make them both negative. Negative 2 and negative 2 will add up to a negative 4. And when I multiply them, they'll multiply to a positive 4. So now that I have it factored, I can set each of these parentheses equal to 0. So that way I can solve them. But again, writing out this second equation is a little unnecessary because it's the same as the first. So when I add the 2 over here, 0 plus 2 is 2. So that's going to be my answer. And I could write it down over here as well. But it's the same answer, so I don't have to mark it down both times. Okay, so let's take a look at the last one. Well, again, I've got a fraction set equal to a fraction, so I'm going to cross multiply. I'm going to write down what I'm multiplying here. I've got a 7x times 2. And then when I cross multiply here, I'm going to write this monomial, the term that's just one term by itself, the 5x. And then I'll write my binomial, the two terms, in parentheses, x plus 1. So now here I can multiply the 7 and the 2, so I get a 14x. And then in the other side I have to distribute. So this time I'm multiplying 5x, a number and a variable, to the x and to the 1. So x times x is going to be x squared, and then there's going to be 5 of them. And then 5x times 1, that's just 5x. So now this one's the most challenging because I have an x squared term and then I have two x terms. And I don't have any constant terms, any terms that are just numbers by themselves. So that means I have to get my x terms together. And again, I want to combine them on the same side of the equation that has the x squared positive. And this is a positive 5x squared. So that means I want to move everything over to the right side of this equation. So I'm going to subtract the 14x over, and I'll be able to combine it with the 5x. Because they both have x's, so they're like terms. So 5x squared minus 9x will be equal to 0. Now I can still factor this to solve it, except I'm not going to do guess and check. I'm going to do that very first type of factoring that often gets overlooked, and that is taking out a greatest common factor. And both of those terms have an x in them. So then I'll have 5x minus 9 as my leftovers after I take an x out of the first term and an x out of the second term. Now again, I'm going to set both of these equal to 0. This little x that I took out as my GCF will get set equal to 0. And then the stuff in the parentheses, the 5x minus 9, that will also get set equal to 0. So this is already solved, x equals 0. That's one of my answers. Now over here I have a little two-step equation that I have to solve. To add the 9 over, and then divide by 5. Oops. So I will get x equals 9/5. So again, I have a fraction for an answer, and I have 0 for an answer, but that's okay. Those are acceptable numbers. 0 is a number, 9/5 is a number. Again, you can write this as an improper fraction. Just make sure it's reduced all the way. If you wanted to write it as a decimal, you could, but 9/5 is a little more precise, and then it saves you the step of having to actually divide it out as a decimal. Okay, so now we have one last example. This one's going to be a little bit easier. It is a word problem, but the proportion that we're going to write will be a little bit easier to solve. But if you do have to write an equation, a proportion, Where you are dealing with a more complicated proportion where there's multiple variables, you have 8 really good examples. Where there's multiple, oh, sorry, you have 4 really good examples to look back at. So here you're making a model of QE2. I'm not sure what that is. I think it might be a ship, like the Queen Elizabeth II. The ratio of the model to the actual size is 1 to 500. So that's an important statement right here that's telling us how we're going to set up our equation. It says the ratio of, so that means we're going to write our fraction, and we're going to write it as the model to the actual size. So that means I want model over the actual size as my ratio, as my fraction. And that ratio is 1 to 500. And it's going to be inches. So for every 1 inch in the model, that's 500 inches in the actual ship. So now we have to keep reading for the rest of our information. It says the model is approximately 23.1 inches long. How long is the actual? So they're telling us more information about the model, and they want us to find the actual. So we have to do a proportion here, so I have to set a fraction equal to another fraction. And again, we're following this order here, where the numerator is the model and the denominator is the actual. So here in my numerator, the model is 23.1, so I'm going to put that here, 23.1. The model goes in the numerator. And then how long is the actual? We don't know, so that's where I'll put my variable. That's what I'm finding. So writing this proportion is the tricky part here in the word problem. But look for that sentence where it tells you how you can write your ratio. And use little variables over here, or write it out in words if you need to. You can write model over the actual. So that way you know what order to set your ratios or your fractions up in. And now we're just going to cross multiply and solve. So I'll have 1 times x equals 500 times 23.1. Now this is a nice proportion to solve because I just have one variable. And here I'm even multiplying it by 1. So x equals 500 times 23.1. So that's going to be 11,550 inches. And you could write your answer in inches. They don't really tell us. But when we're talking about a big ship, we don't really say that it's 11,000 inches long. That's a little hard for us to comprehend and visualize. Usually we talk about stuff in feet. And since there are 12 inches in a foot, if we divide this by 12, then we'll get the answer in feet. So that's 962.5 feet. So that's a little bit more user-friendly answer. If you were talking to someone about this ship, you would say it's 962.5 feet long. That's a little bit easier for us to comprehend and put into a visual image. If you say 11,550 inches, that's a little hard to make sense of. But again, either answer would be correct because they don't tell us exactly how they want the answer. And they were giving us the problem in inches, so if you answered it in inches, that would be completely correct. But just remember that we can convert between units. So if you have to do some of that on your homework as well, ask. If you forget how many inches are in a foot or how many feet are in a yard, you can ask about those conversions. So homework for tonight then is to practice these problems, and you might have to set up the proportion or it might be given to you. Some of these might be very straightforward proportions where you just have to cross multiply and divide. Some of them you might have to distribute and then combine like terms. Remember, you distribute, combine like terms, undo addition and subtraction, then undo multiplication and division. And look back at example 2 where we had those problems where after you cross multiply, you have to distribute and then combine your like terms and then factor. So those are the tough problems where you have to do your factoring. And if you weren't really good at mastering the factoring concept in the previous chapter, here's another chance to practice at it and get really good. That concept of factoring isn't going to go away. You're going to see it next year in geometry and then the year after that in algebra 2. So it's a very basic math concept that you have to understand and know how to do. So practice these problems. If you have questions, come on in and see me before school, or you can talk to me in class as well.